Welcome back. Okay, so we're going to look at vertical shifts, and I have two examples for you, and then we'll look at all of it all together. All right, so here we have some vertical shifts, and this particular graph, I have my grid here. I have my key values, cosine. This is the fourth cosine graph in a row I've done. Waiting to switch over to do some sine graphs now. But there's my values for cosine at all the key points, 0, pi halves, pi, 3 pi halves, and 2 pi. This particular graph will not have a phase shift. There's nothing added to x. So I am going to put a cross there. There's no phase shift on this one. All right, well, let's find everything else. All right, so first, let's see if we have a period change. Okay, well, let's take a look at b. b is the coefficient in front of x. It is 3, which means we have a period change because it's not 1. So that means the period will be 2 pi divided by 3. Okay? So our key points are going to occur at 2 pi thirds divided by 4, which is the same as 2 pi thirds times 1/4, which is pi 6. We've had this as a period change before. All right, so I'm just going to count by pi 6. So start at 0, and then pi 6, and then 2 pi 6, and 3 pi 6, and 4 pi 6. Oops. And you can't, oops, no, I don't want to move you. I just wanted to move these values up so you could see them. Maybe I can lock it in place or something. Let me see, try it one more time. Aha, there we go. Okay, there, now we can see it a little bit better. All right, and I can rewrite 2 pi 6 as pi thirds, and 3 pi 6 as pi halves. We've had this one before. So now because of the period change, because our b is not 1, our graph here is horizontally compressed. It's going to go through the cycle in just 2 pi thirds. Okay? So instead of 2 pi. So it's going to take a third of the time. I'm just going to write this a little bit nicer. So this was 4 pi 6, which is 2 pi thirds. And notice this is always the last value in the period because we've just divided the period into 4 parts. Boy, I guess I should just finish off my lines here, shouldn't I? All right, so we've got our new x values. Matter of fact, that's it for our x values. So let's see if there's an amplitude change, and we'll graph our base graph. And then we'll find the vertical shift, and we'll graph that one as well. All right, so our new y values, we have an amplitude change. The amplitude is 2, and then we also have a reflection. Right, so we're also reflected over the x-axis. So let's do both things at once and multiply everything by -2. So hopefully you realized that there's our amplitude change. It's the coefficient in front. So just multiply everything by -2, -2. There we go. And I'm not missing anybody, but we're a little smooshed here because I moved things down a little bit. There. Oh, of course, they have to all stay together. I'm just going to rewrite that. So these are not so smooshed together. Well, that'll have to be. So that we can read across when we're going to graph. All right, so if you multiply by -2, we get our new y values, -2, 0, 2, 0, -2. So our base graph, before there's any translating there, our base graph is y equals -2 cosine 3x. So I'm going to graph that, and then we'll find our vertical shift. All right, so I'm using the new x values and the new y values. So, and let's put some numbers on this thing. Not a very big graph. So let's go up by pi 6. This then, therefore, 2 lines is pi thirds, and 4 lines is 2 pi thirds. And then lots of space going this direction. I guess each one of these, I don't know. Let's just make each one with 1. 1, -1, 2, -2, and so forth. All right, so our base graph, therefore, is the point 0, -2, and then we have pi 6, 0, so that would be right here, right there, halfway between. Pi thirds, 2. Pi halves, which is the same as 3 pi 6, so 1, 2, 3 right there, and it's at 0. And then 4 pi 6, or 2 pi thirds, is -2. So here's our base graph. Okay. Now our vertical shift. Okay. So our vertical shift is just plus 3. It's 3 up. Okay. So you could, it's much easier to count the vertical shift than it is the phase shift. If you want to just count your points up 3, I'm okay with that, but I'm going to write it down 2. So it's not a bad idea to write it down, just double checking yourself. I'm just adding 3 to all these points here. So if I add 3 to -2, I get 1. 0 plus 3 is 3. 2 plus 3 is 5. 0 plus 3 is 3. And -2 plus 3 is 1. Okay, so notice they still have that same shape. They've just been shifted up 3. Now, before I graph these points, let's graph the midline. So the midline, I'll do it in purple here. The midline is the axis that your graph is oscillating about. It's the same as your vertical shift. So my midline is y equals 3. So I'm going to graph that line because I want to make sure that I'm symmetric across that line. All right, so there's my midline. And now let's graph our new graph, which is y equals 3 minus 2 cosine 3x. So notice your vertical shift could go in front, or it could have been written y equals -2 cosine 3x plus 3. They are the exact same thing. Okay? So I'm just going to, all my points go up 3. So now I've got the point 0, 0, 1. And we have the point pi 6. So I'm using now, this is my x and this is my y. So pi 6, 3, which just means it's moving up 3, 1, 2, 3, right? And it was right on the x-axis. Now it's right on the midline. And I've got the point pi thirds 5, so it's 3 from where it was, and notice it's up at 5. And then we have the point pi halves 3, so that's also going to be right on the midline. And then, of course, 2 pi thirds 1, and there we go. There's our graph. All right, so domain and range, and we're going to do the domain and range on the translated graph. The domain is always all real numbers. The range is now changed because we have, not only do we have an amplitude change, but we've also shifted up. So the low value for my range, you can see it right in the graph, it's 1. That is a minimum value there. Right, because -2, well, originally it was 1, or -1, that was our minimum, and then amplitude change, now it was -2, and then a vertical shift, now it's 1, because it moved up 3. So my range is 1 to 5. There we go. Okay, so vertical shifts are going to change your range. All right, so I hope you're good. Hopefully this one was okay. Let's graph one more with the vertical translations, and let's just throw it all in after that. Have everything. Phase shifts, vertical shifts, period changes. This one has no phase shift. All right. And so I didn't put our x values in here. And my y values, what's wrong with me? All right, I'll do it real quick. 0, pi halves, pi, 3 pi halves, 2 pi. And then cosine again. What is this? The fourth, the fifth, sixth? What? How many cosine graphs are going to do? Hopefully I got a sine graph written in here. That's probably got all the stuff in it. We got 1, 0, -1, 0, 1. All right, and we have, first of all, let's find if we have, why did I write in phase shift on by x? That's not supposed to say phase, that's supposed to say period. My new x, the first thing I find is, do I have a period change? Never find the phase shift before the period change. All right, so my b is the coefficient in front of x, it's 2. Which means the period is 2 pi divided by 2, or pi, which means my key points occur at pi divided by 4, pi fourths. So we still start at 0 and we count by pi fourths. So 1 pi fourth, 2 pi fourth, which is pi halves, 3 pi fourths, and 4 pi fourths, which is pi. There we go. There's our new x values, and let's find our new y values, and we'll graph that as our base graph. So we do have an amplitude change. Our amplitude is 3, coefficient in front of cosine there. So I'm just going to multiply these y values by 3, and that will give me my base graph with the period change and the amplitude change. And so we got 3, we got 0, we got -3, we got 0, and we got 3. I'm going to graph this for my base graph. So my base graph here, actually I'm going to write it over here because probably I'm going to run out of space. Base graph is y equals 3 cosine to x. Let's go up by pi fourths. That seems to be sensible. So I'm just going to label pi halves and pi, but each of those lines, and I'll label this one too, is negative pi halves. It looks nice. I'm just going to label every other one, but each line is a fourth. And then this can just be -1 and 1. That's fine. And that's all I'm going to write down. All right, so we'll graph our base graph with our period and amplitude change. That'll be 0, 3, and pi fourths 0, and pi halves -3, and 3 pi fourths 0, and pi 3. So this graph here is vertically stretched from the amplitude change. Oh, I just missed my point. And that just looks kind of not so good. And horizontally compressed, that looks so not so good. Let me try it one more time. And horizontally compressed because of the period change. So it goes through the cycle faster. So just in half the time, just pi. There we go, that looks a little bit better. All right, so now let's graph our translation. We just have a vertical shift. Our vertical shift is down 2. -2 or down 2. So we're going to subtract 2 from all of our values from the amplitude. So 3 minus 2 is 1. 0 minus 2 is -2. -3 minus 2 is a -5. 0 minus 2 is -2. And 3 minus 2, of course, is 1. So notice, our values there follow a pattern. And I am okay with you counting down. It is not that hard to count down. It's much easier than counting the phase shift anyhow. All right, so let's graph our translated graph here, which is y equals -2 plus 3 cosine 2x, and it's just shifted down 2. So I have the point 0, my shadow keeps blocking. I can't see the whole graph here. 0, 1, or we could just count down to, right? 0, 1, and then we're at pi fourths negative 2, pi halves negative 5, 3 pi fourths negative 2, and pi 1. And there is our graph, just shifted down to. Not too bad, I hope. Domain and range. So domain, I'll put it right here. Domain, of course, is never going to change, negative infinity to infinity. The range here, we have the low value at, oh, I need brackets. We have our low value here. Oh, there goes my pen. And of course, now it's going to write in green. I just knocked my pen over. You don't know that because you're not here, but I did. So our low value is negative 5, and the high value is 1. That's our maximum. And that's it for vertical translations. Not bad, huh? So the next podcast, which I'll come back and do tomorrow, is just for you. We've got everything. Look at this. We've got a vertical shift. We have an amplitude change. We have a period change and a phase shift, and we got to remember to factor out B. So I have put here a handy dandy list of all the steps you could ever want or need for graphing when you've got all this stuff. And look how far you've come. You're going to be able to graph y equals negative 1 plus 2 sine 4x plus pi. Bet you never thought you could do that, but you can. All right, I'll see you in the next podcast tomorrow. All right, so see you later.